Example 4. Determine the maturity value of a $25,000 investment after 15 years. If the interest rate is 9% compounded semi-annually for the first 10 years, and then changes to 10% compounded quarterly for the remaining 5 years. Let's start by getting a handle on the time diagram. We've got a 15-year timeline here, so I think I'm going to extend the timeline a little bit and make it a little bit longer. And we've got 0 to 10 years. And then we've got another 5 years to get me out to the 15-year period. And I know that I have an investment of $25,000, so that's my principal. My principal is $25,000, or my present value is $25,000. So what other factors do I need to consider? First of all, for the first 10-year period, we know that the interest rate is 9% compounded semi-annually. So let's make a note of that, 9% compounded semi-annually for the first 10 years. And we have an interest rate that changes to 10% compounded quarterly for the remaining 5 years. So the interest rate is 10% compounded quarterly. Let's make a note of those two rates. Well, we have the nominal rates than the compounding period, so what we need to do is figure out what the rate per period is. And in the first case, for the first 10 years, we've got an interest rate of 9% divided by 2, or 4.5% per semi-annual period, or per 6-month period. Let's make a note of that. That, of course, tells us that over that time period, over that 10-year time period, we've got a total of n is equal to 10 years times 2 periods per year, 20 semi-annual periods in that first 10-year period. Now, for the next 5 years, we've got an interest rate of 10% compounded quarterly. That's 4 times per year. So the interest rate per quarter would be 10% divided by 4, or 2.5% per quarter. Making a note of that, that tells us that we are forced to count number of quarterly periods over that time period. So we've got a 5-year time period, 4 quarters per year. So n is equal to 20 quarterly periods in that 5-year time span. So I think now we're ready to do the calculations. We can do this in 2 steps, or we can do it actually in 1 step. So what I'll do is I'll show you how to do it in 2 steps, and I will then demonstrate to you how you can calculate it all in 1 step. First step is going to be to take that $25,000 and determine the future value of that $25,000 after the first 10-year period. So step 1 is to find the maturity value of the $25,000 with compound interest added to it at 1.045, 4.5% per 6-month period for 20 semi-annual periods. That gives us, according to our calculations, that gives us a maturity value of $60,292.85. And that's the maturity value of the $25,000 after the 10-year period. So now we have $60,292.85 at that time period. Now, step 2 is going to be to take that $60,292 and add compound interest to that for the next 20 quarterly periods. So now we're going to find the second sum after the 15-year time period of, let's see, $60,292.85 multiplied by the compound interest factor, 1 plus 2.5% per quarter for 20 quarterly periods. So that would be 1.025 raised to the power of 20. And that gives us a maturity value of $98,796.86. So the maturity value after the 15-year time period is $98,796.86. Now, how would you do this all in 1 step, you might ask? Well, it's very simple. If we're starting off with, in 1 step, if we're starting off with $25,000, then what I would do is I would say I'm going to have a maturity value of $25,000. add to that the compound interest of 1.045 for the power of 20, add compound interest to that for the first 10-year period, and then take that amount and multiply that by the compound interest factor of 1 plus 2.5% per quarterly period for 20 quarters. So you can do this in one step now, and you will end up with a maturity value of $98,796.86 again. So you can multiply the compound interest factor for the first 10-year period, and then multiply by the compound interest factor for the last 5-year period in sequence, one right after the other, and come up with the same conclusion.